My warm regards and best wishes to everyone. Today I shall give a presentation on the elementary ideas of stereochemistry. Preliminary concept of stereochemistry. I am Dr. Mrittika Mohar, Assistant Professor of Sri Singh College, Jiaganj, Murshidabad, West Bengal. So let me proceed. So to describe the subject, I shall first explain the term chirality. Let us know what is chirality. What is a chiral object? A chiral object has a non-superimposable mirror image. One of a very good examples of chiral object is human hand. Let us imagine our right hand. So if we take the mirror image of right hand, it is nothing but the left hand. And vice versa, we can say that left hand is nothing but the mirror image of right hand. But if we want to superimpose right hand on our left hand, that is, if we want to superimpose right hand on the mirror image of right hand, it will never superimpose. That means human hand is a chiral object. And then what is a chiral? Here we have shown a chair and its mirror image. It can be easily seen that if we superimpose the mirror image on the real chair or the real chair on the mirror image of the chair, it will be perfectly matched. That means this chair is achiral. Same thing is followed in the molecular world also. Here we can see a lactic acid, a molecule of lactic acid, and we can see as well as the mirror image. These two are not superimposable to each other. That means it's a chiral compound. They differ in their configuration. And these two isomers, why isomer? Because from the elementary idea of isomer, we know that chemical formula is same, but structure is different. What is different here? We shall use a term in the context of difference of their structure, that is configuration. So they differ in configuration. These two are called enantiomers, a kind of isomer, rather say stereoisomer. To explain the term stereochemistry, we shall in a word or in a sentence explain that it's the branch of science which deals with structures in 3 dimensions. They have huge application in biological system, in the development of therapeutic agents, in the sense of our taste, smell. Let me give examples. We can see 2 compounds here and 2 of our very favorite and very known fruits. So these 2 differ in their smell, look, especially in their smell. What causes the difference of the smell? These 2 compounds, plus limonene and minus limonene. We can see the structure is almost same except at one point. That is, they are different in the configuration of the star marked carbon, that is the chiral carbon. And if we can remember the example of plus glucose and minus glucose, both taste sweet, but only one can be digested by the human body system, and the other, I mean the minus one, just gets out of the body with the excreta. And in therapeutic agents also, the stereochemistry has huge role. We can see there are 2 compounds, plus thalidomide and minus thalidomide. So doctors used to prepare the mixture of it. They never separated it for the, it has an application for reducing the nausea effect in pregnant women. but it was found that children are born with defective organs, as we have shown here. It was found that the minus thalidomide is responsible for that. So for after that, the medicine was banned. So one medicine is beneficial, one is harmful, just because of the enantiomerism. So you can see here two enantiomers again. So what are enantiomers? I have already told. This shows this show same physicochemical properties like melting point, boiling points. So what is different there? The interaction with plane polarized light. If we pass plane polarized light through the solution of a compound, suppose I have already shown plus or minus compound, suppose a plus compound, then if it rotates the plane of plane polarized light just by 30 degree, another will rotate it by on the right hand side. If we then the another one will rotate it in the left hand side by the same amount of angle. So we have mentioned the things R and S in the previous name. So what are the R and S? To differentiate the enantiomers, we have brought this nomenclature, and it has been done by Kahn, Ingold, Krylov, three scientists. What have they done? They have given the substituents priority based on their atomic numbers. The highest atomic number gets the highest priority, lowest one gets the lowest priority. So if we view the compound with the lowest priority substituent pointing away from us, us mean the observer's eye, then we can draw a circular arrow from connecting substituents from first to the third, that is the highest to lowest priority. If the arrow moves clockwise, it is labeled as R. Rectus, if the arrow moves counterclockwise, then it is S. That is the mystery of R and S. So the preliminary concept of stereochemistry has been described. Thank you for your patience.